Hello friends, in the last video we have looked at what is a graph and how we represent the nodes, the edges, and the graph can be directed, undirected or weighted. And we have also looked at the array representation and linked representation of a graph in a programming language. Now in today's video we will look at the BFS algorithm, that is the breadth first search algorithm, and in the subsequent video we will look at the depth first search algorithm. So let us continue. So talking about the BFS algorithm, breadth first search algorithm, first let us do one example. Of breadth first search, and then we will write the algorithm for it. Believe me friends, the algorithm is very simple, and just by a simple example the crux of the algorithm will be clear to you. So let us use a very simple small example for BFS. So I have a graph like this where this is A, B, C and D. Now what BFS will do is it will visit the source node or the first node in the graph, and then whatever nodes are connected to it, they will be visited first. Then the second relation, that is the nodes connected to the first level nodes, then nodes connected to second level nodes, and so on. That means first, suppose A is the source, so the nodes to which A is directly connected, they will be visited first. And if anything is left after that, then that will be visited. Suppose we have another edge over here, E. So I am going to take this simple example where A is connected to B, D and C and E is connected with B. Now we are going to maintain a queue data structure. So what we have in a queue is there is a front, there is a rear, and the elements are removed from the front and added to the rear. That is the working of the queue. That is a first in first out. जो element पहले आएगा वही element पहले बाहर जाएगा. So that is the working of the queue. So we will maintain a queue and we will have the source with us. So what we will do is we will put the source on the queue. So we will add the node onto the queue. Then what we will do is we will dequeue it, we will remove it from the queue and we will expand its children. So A जिससे connected है वो सारे nodes हम list कर देंगे. So A is connected with B, A is connected with C and A is connected with D. So the three entries we will make here. Now A जो है वो exhaust हो गया, it doesn't have any other child, so we will mark it as finished. Then we will move on to B. Now B is not yet expanded, so we will remove B from the queue and we will expand its children. So who all are connected with only B, or those nodes which are not already present on the queue and are connected with B will be listed. So C and D are already on the queue. The node which is not on the queue is E. So we will put E on the queue. Now we will mark B as red. Then we will move ahead. The next node is C. Now C doesn't have a node which is not on the list. So we will not expand C further because there are no nodes available. And we will mark C as red. Then we will go to D. D doesn't have a unique child. So we will mark this as red. And similarly we will do with E. And the breadth first traversal order is A, B, C, D and E. They are listed in the same order. Now let us take another example. Suppose we have a graph like this. We have the node B with us. Then there is A and a B, C, and there is a D and E node. Suppose these are the nodes that are available to us and the source is B. Now how we will evaluate this graph? If we will start from B, first B is put on the queue, then we will find out all the children of B. So all children of B in the alphabetical order, first is A, then C, then D, and then E. So all the children are listed in the same order. There are no more children of B. So we will stop here. Suppose there was yet another edge. This is F. And suppose there was another edge G over here. Now B is finished. We will remove A from the queue. Now A doesn't have any other child which is not yet listed on the queue. So we will mark A as red. Then we will read C. C has a new child F which is not present on the queue as yet. So we will put F on the queue and we will mark C as red. Then D doesn't have a child which is not on the queue, which was or which is not on the queue, and therefore D is marked as red. Then E, it doesn't have a child. Yes, it has a child. It has a child G. So we will put G on the graph Q and we will mark E as red. Then we will visit F and then we will visit G. So the order in which the nodes are getting identified, in the same order we are visiting them. Now let us do the graph for this particular algorithm for this particular breadth first search. So first of all, what we are going to do is we will define the BFS function and we will receive the source node as an argument. Then what we will do is, first of all, we will change the color of S as gray. Now what is this color? In the initialization for the algorithm, we will define a color matrix where each node will have a color, and initially all the nodes are white, and then the moment they are added to the queue we make them gray, and the moment they are dequeued and all their children have been expanded, they will be marked as black. So initially whatever source node we receive, we mark it as gray and we put it on the queue. So NQS. Now the condition is while the queue is not empty. While our queue is not empty, what we will do is we will first of all dequeue and we will read this value into a variable. We will dequeue from the queue and then what we will check, all nodes adjacent to U and with color white will be enqueued. So all nodes which are adjacent to U and have a color white will be enqueued. So this means if in the graph there is an edge between U and I and color of I is equal to white, then what we will do, we will set color of I as gray and we will enqueue it. Enqueue I. We will put it on the queue. And this thing we will repeat for all nodes I is equal to 0 to n. So this will continue, and after at the end of this for loop, all the nodes adjacent to U will be there on the queue, and then we can mark U as black. That means we have already read, we have already expanded it. So we will say color of U is equal to black. And this thing we will put in the bracket because this thing is to be done in the while loop. So in the while we will see till the queue is not empty and we are adding elements in the body to the queue. So when the queue is empty, that means there are no more nodes to be expanded. I hope this video is useful to you. Thank you very much.